Welcome to today's class. Today we shall deal with chemical kinetics. So what is meant by chemical kinetics? What is meant by chemical kinetics? What are the factors we have to study under this heading? So chemical kinetics implies the branch of chemistry which deals with rates of the reactions and their mechanisms. Rates of the reactions and their mechanisms. So chemical kinetics can be applied only to the moderate reactions. What do you mean by moderate reactions? Reactions which proceed with measurable velocities are called moderate reactions. Chemical kinetics cannot be applied either to the instant reactions, instantaneous reactions, or very slow reactions. Because what do you mean by instantaneous reactions? The reactions which get completed at the moment of mixing of the reactants are called instantaneous reactions. What are the examples for instantaneous reactions? Acid base neutralizations and precipitation reactions, for which we cannot apply for such type of the reactions chemical kinetics cannot be applied. Chemical kinetics can be applied only for the moderate reactions. What do you mean by moderate reactions? The reactions which proceed with measurable velocity. Now what is rate? What is rate? What is rate? Rate is defined as, in case of solutions, rate is defined as dC by dt. What do you mean by dC? Change in concentration. What is meant by dt? Small interval of time. In case of solutions, dC can be, dC is equal to dNV by dn delta n by V. What is meant by delta n? Change in number of the moles by volume in volume of the solution. Change in number of the moles by volume. So, but change in number of the moles by volume can also be given as delta P by RT. Delta P by RT. So, in case of gaseous reactions, rate can also be defined as rate is equal to dP by dt. Rate is equal to dP by dt. dP by dt. So, to understand this, we can a hydrogenation reaction. During the hydrogenation reaction, the pressure of the hydrogen is reduced from 2 atmospheres to 1.2 atmospheres, 2.2 atmospheres to 1.2 atmospheres in a span of 50 minutes. In a hydrogenation reaction, the pressure of the hydrogen drops from 2 atmospheres to 1.2 atmospheres in 50 minutes time at a temperature of 25 degrees centigrade. We can express the rate of the reactions in terms of concentration as well as in terms of pressures also. In terms of pressure, rate is equal to directly dP by dt, 2 minus 1.2 by what is the time interval? 50, 0.8 atmospheres by 50 minutes. This is how we have to express the rate of the reaction in terms of change in the dP by dt value. In terms of concentration, what is rate? Rate is equal to dC by dt. Rate is equal to dC by dt. Now, what is the value of dC? dP by RT. What is the value of dC? dP by RT into 1 by dt. What is the dP value? 0.8 atmospheres. What is R? 0.0821. What is T? 298 and 1 by 50. So, these are the methods of expressing the rates with respect to the pressure, with respect to the concentration. What is concentration? Nothing but moles per liter. So this is the way of expressing the rate of the reaction. In case of what are the units for rate? What are the units for rate? Moles per liter, mole, liter inverse, time inverse, mole, liter inverse and time inverse. What are the general characters of the rate of the reaction? No reaction proceeds with uniform rate. No reaction proceeds with a uniform rate, because as time proceeds, concentration of the reactant goes on decreasing. Therefore, rate of the reaction also decreases. Only exception is for zero order reactions. So, among all reactions, only zero order reactions proceed with uniform rate, because in zero order reactions, rate of the reaction does not depend upon the concentration. So, there are two ways of expressing the rate of the reaction. One is average rate and other one is instantaneous rate, instant rate. What do you mean by average? Both in the average rate and instant rate can be determined graphically, when we take a graph between concentration and time, we get a curve, because concentration varies with time exponentially. So, to get the average rate, two tangents will be drawn at T1 and T2. What is the concentration corresponding to the T1? C1. What is the concentration corresponding to time to T2? So, average rate is equal to C1 minus C2 by T2 minus T1. Now, what is other way? What is the other method of expressing the rate? Instant rate. What do you mean by instant rate? Mathematically, the rate of the reaction at a particular instant of time is called instant rate. Mathematically, how do you define instant rate? Rate of the reaction when D2 tends to 0. When D2 tends to 0. How do you measure that? To the concentration time curve, we draw a tangent at a particular instant of time. That tangent will be extended to meet the concentration axis at A and time axis at B. And what will be the rate? Rate will be equal to OA by OB. This is the concentration axis, this is the time axis, this is at a particular time, at a particular instant of time, we draw a tangent to the curve, and that tangent, that normal will be extended to meet the time axis at B, concentration axis at A, and rate will be equal to OA by OB. So, these are the general methods of determining the rates of the reaction. And what are the factors that influence the rate of the reaction? One concentration, and the other one is temperature, and other one is, so the three main factors: one concentration, two temperature, three in presence of catalyst. In general, rate of the reaction is directly proportional to the concentration. Rate is proportional to concentration to the power of n. In case of gaseous reactions, rate is proportional to the pressure to the power of n. What does it mean? When the concentration is changed by x times, rate of the reaction changes by x to the power of n times. Now, why rate of the reaction changes with the concentration? When concentration is increased, the number of moles per unit volume increases. As a result, effective collisions increases, collision frequency, thereby effective collisions increases. That is why rate of the reaction increases. Now, what is the effect of the temperature? For every 10 degrees rise in temperature, rate gets doubled or tripled. So, it is expressed as, temperature coefficient is expressed as kT plus 10 by kT is equal to 2 or 3. What is kT plus 10 by kT? kT plus 10 is the rate constant corresponding to the temperature of T plus 10. Kt is the rate constant corresponding to the temperature T. It is equal to 2 or 3. What is the general range of the general interval of the time where the temperature coefficient is determined? K35 to K25. K25, it is equal to 2 or 3. Now I will discuss the salient features of the collision theory. So what will happen for a chemical reaction to take place? Collisions are necessary. Collisions must take place with a certain amount of energy called threshold energy. Collisions which lead to a chemical reactions are effective collisions. Based on energy, there are two types of molecules. One is activated molecules, other one is normal molecules. What do you mean by activated molecules? Whose energy is equal to threshold energy, their collisions are effective. What do you mean by normal molecules? Whose energy is less than threshold energy, their collisions are ineffective. Normal molecules become activated molecules by gaining additional energy. That additional energy is known as activation energy. What is the relation between activation energy and rate of the reaction? Inverse relation. Rate is inversely related to the activation energy, and Arrhenius proposed a relation to give the relation between rate constant, activation energy and temperature, which is taken as K is equal to A into e to the power of minus EA by RT. Log K is equal to log A minus EA by 2.303 RT. A by 2.303 RT. When a graph is drawn between log K and 1 by T, we get a straight line with a negative slope. What will be the slope value? Minus EA by 2.303 R. Log K2 by K1 is equal to log K2 by K1 is equal to EA by 2.303 R. 1 by T1 minus 1 by T2. Let us do some numericals on this. Let us do some numericals on that. For a given reaction, the expression for log K is given as follows. Log K is equal to 14.3 minus 1.25 into 10 to the power of 4 by T. Log K is equal to 14.3 into 1.25 into 10 to the power of 4 by T. From this, we have to find the value of A, and activation energy. This is the problem. Now, what is the general expression? Log K is equal to log A minus EA by 2.303 RT. This is equation 1. This is equation 2. From 1 and 2, when we compare 1 and 2, log K is equal to log A is equal to 14.3. Therefore, what will be the A value? 10 to the power of 14.3, which is equal to 2 into 10 to the power of 14. We have to take the antilog for 0.3. What is the antilog for 0.3? 2. So 2 into 10 to the power of 14. If you apply logarithms, we'll get back log A will be equal to 14.3. Next, minus EA by 2.303 RT is equal to minus 1.25 into 10 to the power of 4 by T. by T. So activation energy will be equal to 2.303 R into 1.25 into 10 to the power of 4. If you take the R value in joules, we will get the activation energy in joules. If you take the R value in calories, we will get the activation in energy in calories. This is the way to solve the numerical. What is given? This is the expression given from which we have to find A value and activation energy. This is the standard relation. We have compared the standard relation with the given relation. We got these results. Now another important point is at a given temperature, or at a 25 degrees centigrade, K is equal to X, and K is equal to X, A is equal to Y, and activation energy is equal to Z. At a temperature of 25 degrees centigrade. These are the hypothetical parameters. Just to understand the concept, we have taken these hypothetical values. Now what is the question? At infinity, what is the value of K? At infinity, what is the value of K? So K is equal to A to the power of minus EA by RT, when at infinity, when temperature tends to infinity. What is the value of K? When T tends to infinity, K will be equal to A. So what is the value of A? It is Y. K will be equal to Y. And when activation energy also tends to 0, then also K will be equal to A. So when the rate constant will be equal to Arrhenius parameter, whether when temperature tends to infinity or activation energy tends to 0. In both the cases, rate constant will be equal to Arrhenius parameter. That is an important. In which case activation energy will be 0. In radioactive process, activation energy will be 0. So when temperature tends to infinity or when activation energy tends to 0, K value will be equal to A. Next, we will do a small numerical. A reaction take place in 3 steps. The rate constants at each steps are K1, K2, K3. And activation energies are respectively 50, 40, 30. Kilojoules. Now, the overall rate constant is given by the expression K is equal to K1 K3 by K2. Then what is the overall activation energy? This is a question. Reaction take place in how many steps? 3 steps. K1, K2, K3 represents rate constants at each step. And what are the activation energies for each step? 50, 40, 30. And what is the expression for the rate constant for the overall reaction? K is equal to K1, K3 by K2. Then what is the activation energy for the overall reaction? So now we will take from the expression K is equal to A into minus EA by RT. So K1 A into e to the power of minus, for same reaction A value remains the same, EA1 by RT, EA1 by RT into A to the power of minus EA1, EA2 by RT, EA2 by RT by EA3, sorry, EA3 RT, here EA2 by RT. So simplifying it, here A gets cancelled out, A gets cancelled out, and what will be the final expression? Overall activation energy EA will be equal to E1 plus E3 minus E2. E1 plus E3 plus minus E2, 50 plus 30 minus 40, which is equal to 40. This is simple arithmetic operation. This is simple arithmetic operation. So finally, when this expression is simplified, we will get this expression. So what will be the overall activation energy? 40 kilojoules. 40 kilojoules. 40 kilojoules. Next, a particular reaction is carried out. A particular reaction is carried out in the absence of catalyst. In the absence of a catalyst, a particular reaction is carried out in the absence of catalyst at 500 Kelvin. At 500 Kelvin, and in presence of catalyst also. In presence of a catalyst. In presence of catalyst at 400 Kelvin. At a 400 Kelvin. At 400 Kelvin. What is the point? This rate R1 is equal to R2. What is meant by R1? Rate of the reaction in the presence of catalyst. What is R2? Rate of the reaction in the presence of catalyst. What is R1? Rate of the reaction in the absence of catalyst. What is R2? Rate of the reaction in the presence of catalyst. And what is the other point? Catalyst lowers the activation energy. Catalyst lowers the activation energy by 20 joules. Catalyst lowers the activation energy by 20 joules. What is the activation energy? Original activation energy of the reaction. What is the original activation energy of the reaction? So R1 is equal to R2. So generally rates are represented by the rate constants. So K1 is equal to K2. K1 is equal to K2. A to the power of minus EA by RT. EA by RT. So A into E to the power of minus, in the presence of catalyst, EP by RT. What is meant by EP? Activation energy in the presence of catalyst. A gets cancelled out. A gets cancelled out, and R gets cancelled out. R gets cancelled out. What is left over? Minus EA by T. What is the temperature in the absence of catalyst? 50, 500. What is the 400? So it also gets. What is the activation energy? What is the activation energy in the presence of catalyst? 20 minus 20. Why we have taken as minus 20? Because catalyst lowers the activation energy by 20 joules. Therefore, activation energy in the absence of a catalyst will be 100. Solving this. This is the way of dealing with collision theory problems. Another important point regarding the collision theory is calculation of the heat of the reaction. In a reversible reaction, activation energy for the forward reaction is equal to ET minus ER. What is ET stands for? Threshold energy. What is ER stands for? Energy of the reactants. Activation energy for the backward reaction EB is equal to ET minus EP. So EF minus EB will be equal to EP minus ER, which is equal to delta ER delta H. Delta ER delta H. This is also one of the important relation from based on which we can expect questions. We'll do a small question on this concept. A gives rise to B. In this, the delta E value is given as minus 33 kilojoules. EF by EB, ratio of activation energy of the forward reaction by activation energy of the backward reaction is equal to 20 by 31. Ratio is equal to 20 by 31. Find the values of EF and EB. What is the question? Note down carefully. A gives rise to B. Delta E is equal to minus 33 kilojoules. Ratio of activation energy of the forward reaction to the backward reaction is equal to 20 by 31. Find the values of EF and EB. Now coming to the delta E is equal to EF minus EB is equal to minus 33 kilojoules. EF is equal to 20 by 31 EB and minus EB is equal to minus 33. Solving EF is equal to minus 60, EF is equal to 60, EB is equal to 93. EF minus EB is equal to minus 33. What is EF value? 20 by 31 into EB. So solving this, we'll get the EF value as 60, EB value as 93. This is also very important model. What is the other important point to be noted? Suppose if we consider 4 reactions with a different activation energies, when we consider different reactions with a different activation energy, increasing the rate of the reaction will be more, increasing the rate of the reaction with increasing the temperature will be more for the reactions having high activation energy. Coming again, when we consider different reactions which possess different activation energies, take for example, for one reaction activation energy is 50 kilojoules, for one 30, for first reaction what is the activation energy? 50 kilojoules. For the last reaction what is the activation energy? 20 kilojoules. So with increase in the temperature, rate of the first reaction will increase considerably when compared with the other. What is the statement we have to do? Rate of the reactions, when we consider different reactions, the rate of the reaction for which activation energy is more will increase to a considerable extent with increase in the temperature. That is the important point to be remembered regarding the activation energy and the temperature. Now coming to the rate law and order and molecularity. These are the two important subheadings or we have to concentrate. What is rate law? Rate law means for a general reaction, MA gives rise to MA plus NB gives rise to the products. Rate law can be written as rate is equal to K into A to the power of M and B to the power of N. What is rate law? What is a rate law? What is rate law? The expression that gives mathematical relationship between the rate of the reaction and concentrations of the reactants is called rate law. Rate law should always be written based on the experimental results, not based on the stoichiometric equation. Next, what is the order? What is the order? What is order? Some of the powers of the concentration terms that appear in the rate expression. What is the relation between order of the reaction and a concentration? Y is equal to x to the power of z. Y, what is y? What is y? Change in rate. What is y? Change in rate. What is x? What is x? Change in concentration. Change in concentration. What is z? Order of the reaction. This is the simple relation. Order of the reaction. This relation will help us to solve many numericals. What is the other important terms that are to be remembered? Expressions for the rate constant and expressions and characters of the zero order reactions. Which will be zero order reactions? Which will be the zero order reactions? So if any of the reactant is taken in large excess, order with respect to that reactant will become a zero. Why? Because concentrations of such reactants will practically remain constant. Since when concentrations remain constant, rate of the reaction also remains constant. So that is the character of the zero order reactions. And what are the examples for the zero order reaction? Adsorption, decomposition of ammonia on the surface of the metal catalyst. For the adsorption of ammonia on the metal catalyst, rate expression is given as rate is equal to K1 into NH3 by 1 plus K2 into NH3 at low concentrations 1 plus K2 NH3 will be equal to 1. Then rate will be equal to K1 into NH3. In such case, rate follows first order kinetics. At higher concentrations, what will happen? 1 plus K2 NH3 will be equal to K2 NH3. Then rate will be equal to K1 by K2, which is a constant. That is the character of the zero order reactions. At low concentration, if a reaction follows first order kinetics, it can be made into zero order kinetics. So rest of the things we can discuss through the questions. What are the expressions for the zero order rate constant for zero order? K is equal to A naught minus A by T. And for first order reactions, K is equal to 2.303 by T log A by A minus X. So if any concepts are left over, we can discuss through the questions. Now we'll start discussing the questions. In a reaction, A gives rise to B. When the concentrations of the reactant is made 8 times, the rate gets doubled. What is the order of the reaction? So we can simply use this relation. Y is equal to x to the power of z. Concentration is increased by 8 times. What is y stands for? Change in the rate. What is x stands for? change in the concentration. What is Z stands for? Order of the reaction. Order of the reaction. X is equal to 8, Y is equal to 2, Y is equal to 2. Now we have to find Z. So 2 is equal to 2 to the power of 3Z. So Z is equal to 1 by 3. Z is equal to 1 by 3. Next question. The rate of the reaction A plus 2B gives us to, if B is present in a large excess, as we have earlier discussed that whenever a concentration of any reactant is taken in a large excess, order with respect to that reactant becomes 0. Now in this case, when order with respect to B becomes 0, what will be the order? K, A to the power of 1, B to the power of 0. So overall order will become 1. These reactions are called pseudo unimolecular reactions. What do you mean by pseudo unimolecular reactions? Reactions whose molecularity is greater than 1 but are made to follow the first order kinetics are called pseudo unimolecular reactions. Next. Doubling the concentration of both the reactants increases rate by a factor of 8, but doubling the concentration of B alone only doubles the rate. What is the order with respect to A and B? Now what is the rate expression? Let the rate expression is equal to, rate is equal to K into A to the power of M and B to the power of N. What is the M stands for? What is M stands for? Order with respect to A. What is N stands for? Order with respect to order with respect to the N. We can simply use this relation y is equal to x to the power of z. Case 1, when concentrations of both the reactants are doubled, when concentrations of both are doubled, then z will be equal to m plus n. Z will be equal to m plus 1. So in the first case, in the first step, when the concentrations of both are doubled, rate increases by a factor of 8. So y is equal to 8 and x is equal to 2 to the power of m plus n. So m plus n is equal to 3. M plus n will be equal to 3 because 8 can be written as 2 cube. What is case 2? When the concentration of B alone is doubled, in this case Z will be equal to n. Z will be equal to n. So what will the y value? 2 to the power of n is equal to 1. Therefore m is equal to 2. Order with respect to A is equal to 2. Option 1 is the answer. Next question. Next, the initial rates for gaseous reactions are given follows. Let us observe the data given. In the first, compare 1 and 2. Compare 1 and 2. So keeping the concentration of keeping the concentration of B as a constant, when rate of the reaction is doubled, when the concentration of A is doubled, we observe no change in the rate of the reaction. That means order with respect to A is equal to 0. Order with respect to A is equal to 0. Why order with respect to A is equal to 0? Even when the concentration of A is doubled, there is no change in the rate. Therefore, order with respect to A will be equal to 0. So let us compare 2 and 3. When the concentration of B is doubled, rate increases by a factor of 4 times. Rate increases a factor of 4 times. When the concentration of B is doubled, rate increases by a factor of 4 times. Rate increases by a factor of 4 times. So y is equal to 4 and x is equal to 2 and n. So n is equal to 2. So order with respect to B is equal to 2. Overall order of the reaction 0 plus 2, 2. So overall order of the reaction is 2. Option 4 is the answer. Next question. So here when the pH value changes from 2 to 1, implies when the pH value decreases, when H plus ion concentration increases, increases implies H plus on concentration is increased by 10 times. Therefore here y is equal to x to the power, applying y is equal to x to the power of z. What is the x value? 10 to the power of z. And what is y? 100 times. Rate increases by factor of 100 times. So 10 square is equal to 10 to the power of z. Z is equal to 2. This is the way when pH value decreases from 2 to 1, to decrease the pH value by 1 unit, H plus on concentration should be increased by 10 times. Therefore x is equal to 10 and rate increases by factor of 100. So this is the way to do it. Next, the initial concentration of cane sugar was of an acid was reduced from 0.2 to 0.1 in 5 hours, 0.05 to in 10 hours time. What is the value of K? So this let us first see the order of the reaction. 0.2 to 0.1 in 10 hours time, in 5 hours time, and from 0.1 to 0.05 to 0.05, another 5 hours, from 0.0 to 0.5 in 10 hours time. So this is nothing but the reaction follows the first order reaction, first order kinetics. What is the main major character of the first order reactions? Half-life period remains constant. Half-life period does not depend upon the initial concentration. Then how to find the K value? What is half-life period? 0.5 hours time. So half-life K is equal to 0.693 by T of 0.693 by 5, that is equal to 1.386. 0.136 only. 0.1386 only. It's option 3 is the answer. Okay. 50% of a first order reaction is take place in 16 minutes, then fraction that would react in 32 minutes from the beginning is, in first order reactions, in first order kinetics, some important tips are T of is to T34, T3 by 4 is to T by 7 by 8, which is equal to T50 is percent is to T75% is to T 87.5% is equal to 1:2:3. 1:2:3. So half-life period is completed in 60 minutes. Then fraction that would react in 32 minutes will be 3 by 4. Because when the initial concentration is 1, in 16 minutes it will be reduced to 1 by 2. In another 16 minutes it will be reduced to 1 by 4. So fraction of the reaction that is completed, fraction of the reaction that is completed is equal to 1 minus 1 by 4, 3 by 4 fraction. It is as simple as that. Next, the time required for the completion of 2 by 3rd of the first order reaction when the rate constant is given, we have to find the time. And what is the expression for the time? To find the time, T is equal to 2.303 by K log A by A minus X. What is A stands for initial concentration and what is A minus X stands for final concentration. Here T is equal to 2.303. What is the K value? 4.771. 4.771 into 10 to the power of minus 2. 10 to the power of minus 2. Now what is log A? We take A as 1. And what is the X value? As 2 by 3. 2 by 3. 2 by 3. Now 2.303 by 4.771 into 10 to the power of minus 2. This will be log 3, whose value is 0.4771. 0.4771. Now what will be the value? This will be 10 times. So one second. The time needed for the completion of the 2 when rate constant is 4.771 into 10 to the power of minus 2, minute inverse 0.2. This will be log 1 by what is left over for the completion? 1 by 3 log 3. So T is equal to 2.303 by 4.771 into 10 to the power of minus 2 into 0.4771. Log 3 value is 0.4771. So it will be 10 into 10 to the power of minus 1. If it goes to the T value must be 23.03 minutes. 23 points. Option 1 is the answer. Option 1 is the answer. For the reaction 2N2O5 gives us to 4NO2 plus O2. Rate and rate constants are given. Then how to find the concentration? So we have to first ascertain what is the order of the reaction. So how to ascertain the order of the reaction? From the units of rate constant. What are the units for rate constant? Second inverse, that is time inverse. To find the order of the reaction from the units of the rate constant, how to get the units for the rate constant? Mole by liter to the power of 1 minus n time inverse. To find the order of the reaction, the power of the mole term must be equated to 1 minus n. In the present expression, there is no mole term, therefore 1 minus n is equal to 0, n is equal to 1. So we have to first ascertain the order of the reaction. So decomposition of N2O5 follows the first order kinetics. How we have ascertained that fact? From the units of the rate constant. In the units of the rate constant, the power of the mole term is 0, which must be equated to 1 minus n. Therefore, n is equal to 1. Now, what will be the rate expression? Rate is equal to K into N2O5 to the power of 1. What is rate? 1.02 into 10 to the power of minus 4. 1.02 into 10 to the power of minus 4. 1.02 into 10 to the power of minus 4. What is rate constant value? 3.4. 3.4 into 10 to the power of minus 5 into concentration. So concentration is equal to rate by K. Solving will get the answer as 3. Next. The half-life periods of 4 reactions labeled by A, B, C, D are 30 seconds, 4.8 and 180 seconds, 160 seconds. The fastest reaction is So lesser the half-life period, more is the velocity of the reaction. So obviously A. What do you mean by half-life period? The time required for the initial concentration to get reduced to half of its value is called half-life period. Shorter the half-life period, greater is the reactivity. Obviously A will have the fastest rate of the reaction. Option 1. 3/4 of the first order reaction is completed in 32 minutes. 15/6 part will be completed in how much? So T is equal to 2.303 by K log A by A minus X. So T1 by T2 is equal to log 3/4 of the reaction 1 by 1 minus 3/4 by, because this will get cancelled out, 2.303 by K log 1 minus 1 by 3/4 1 minus 3/4 by 2.303 by K log 1 by 1 minus 15/16. So simplifying this, we'll get T2 is equal to T1 by T2 is equal to 1 by 2, and T2 will be equal to 2 into T1, that is 64 minutes. What is the alternate way to do this problem? So first order reaction, 3/4 of the reaction is completed by 1 by 2, 1 by 4, and 1 by 8, 1 by 16. When 15/16 part is completed, what will be the final concentration? 1 by 16. For that, how many half-life periods are to be done? From this to this we have 32 minutes. From this to this another 32 minutes. Total time is 64 minutes. This is a simple way of solving the numerical. Next question. Initial concentration of the reactant is 1 m. The concentration becomes in 2 hours. So 1 m becomes 0.9 molar in how much time? 2 hours time. And 0.9 will become 0.8 molar in another 2 hours time. 0.8 molar becomes 0.7 in another 2 hours time. Here what is the point? R1 is equal to 1 minus 0.9 by 2 hours. R2 is equal to 0.9 minus 0.8 by 2 hours. R1 is equal to R2, which is the characteristic property of zero order reaction. So order of the reaction is 0. Next question. Half-life periods for reactions of initial concentration. What is the theory here? Half-life period is inversely proportional to a to the power of n minus 1, or half-life period is proportional to a to the power of 1 minus n. What is T of stands for half-life period? A stands for initial concentration, n stands for order of the reaction. Now what is the A1 here? So T1 by T2 is equal to A1 by A2 to the power of 1 minus n. What is T1? 5 by 50. What is A1? 0.1. What is A2? 0.01. 1 minus n. So 10 to the power of minus 1 is equal to 10 to the power of 1 minus n, n is equal to 2. Or else, what is the simple way of dealing with this problem? When our initial concentration is decreased, half-life period is increasing, which is the characteristic property of second order. Had it been zero order, half-life period is directly proportional to the initial concentration. With the decrease in the initial concentration, half-life period decreases in case of zero order reactions. Next, %, of the first order reaction is completed in, must be 50 minutes. 20% of the first order reaction is completed in 50 minutes time. Time required for the completion of the 60% of the reaction. So here T 60% by T 20%. What is the expression for time period? T is equal to 2.303 by K log A by A minus X. When you are considering the percentage of the reaction, A should be taken as 100, X will be the percentage of the reaction completed. Now 2.303 by K, 2.303 by K log 100 by 100 minus 60, 100 minus 60 by 2.303 by K log 100 by 100 minus 20. What is T 60%? What is T 20% time? 50 minutes. 50 minutes. Log 100 by 40. Log 100 by 40 means log 10 by 4. Log 10 by 4. Here log 10 by 8. Log 10 by 8. Log 10 by 4 means it is approximately equal to 0.4. It is approximately equal to 0.1. So solving that, T 60% is equal to will be equal to 205 minutes. 205 minutes approximately. Next. So here also, this is also a character of the zero order reaction, because what is R1? What is R1? R1 is equal to 0.69 minus 0.052 by 17. And what is R2? 0.052 minus 0.035 by 17. Since R1 is equal to R2, this is a zero order reaction. What is the rate constant of the reaction during the corresponding what is the K value? K value is equal to A0 minus 80. A0 minus 80 by time T. So K will be equal to 0.017 by 17. So option 4 is the answer. Thank you. We'll continue in next class.